This is the solution video for the coordinate geometry worksheet. So the first question, question 1, we've got a line L and we have its equation and we want to find the line K. Now K is perpendicular to L and we also have its y-intercept. So based on this, the easiest way to make this equation is to use the format y equals mx plus c, because I can go directly into this format if I have the slope and the y-intercept. So I have the y-intercept, pretty obviously c is -7, have to just get the slope. I can get that directly from the line L over here. Don't forget, the quick way to get a slope from a line in this format is to use minus a over b. So in this case, a is 1 and b is 2. So the slope of L is -1 over 2. Now that's perpendicular to k, so I'll have to flip and change the sign. And now that I've done that, I have got my slope, which I can call m, and my y-intercept, which is the value for c. And I have my equation then, y equals 2x minus 7. You can also use the other equation of the line formula if you like for this. And of course, in that case, you would just use the point 0 minus 7 because that's the point on the y-axis. Okay, on to part B then. M and N are two lines that pass through the point of intersection of the lines L and K. 6 minus 3 is a point in M, find the equation of M. So if they're passing through the point of intersection of L and K, it might be a good plan to find that point of intersection first. So I've written down the lines L and K. Clearly they're not aligned, so they're not formatted exactly the same. So I should start by doing that. And now I want to cancel out either the x's or the y's. I think in this case the x's are easier. So I'll times that L equation by 2. And this works out quite nicely. I get 5y minus 5 equals 0. I can just solve that then for y. And once I have y, I can sub that back into either L or K in order to figure out the value for x. And so x is equal to 4. So now I've got the point of intersection at the point 4, 1. So that's one of the points that M passes through. M passes through the point of intersection. It also goes through the point 6 minus 3. I want to find the equation of M. I'll use this point that I've just found and this point 6 minus 3 now to get the slope and then proceed to find the equation. It's always a good plan to make a note of the formula that you're going to use. And I fill it in and I get a slope of -2 and then I can proceed to the equation of the line formula. Note that this time I didn't use the y equals mx plus c that I used before because I don't have the y-intercept. So I fill that in and I'll just tidy it up a little bit now. So I've written my equation of my line as y equals -2x plus 9. You can write it in the other format, ax plus by plus c, either if you like. I just like to write it this way because, as we discussed in part A, it shows me my slope and my y-intercept very conveniently in case I need to use those further on in the question. In part 2 of the question, I'm looking at that other line n and I want to find its possible equations if the angle between m and n is 45 degrees. Now, if I'm dealing with the angle between two lines, I've got a formula for that. So tan of theta is the absolute value of m1 minus m2 over 1 plus m1 m2. I'm using this absolute value format because I particularly know here that theta happens to be an acute angle. So I'm going to fill in what I know then. So I've got that theta is 45. I've got the slope of m, which I'm going to call m1, that's -2. And I've got the slope of n, which I'm going to call m2. I don't know what that is, so I'll just keep calling it m2 and I'm going to fill those in. Having filled that in, I actually see that tan 45 is something that I can evaluate. Tan 45 equals to 1. So now I want to see how I can proceed to go ahead and find the solution for this m2 value. So of course, thinking about my absolute value here, I know that this fraction here is equal to 1 or -1. So I've got two possible solutions that I can get from this, which makes sense because they're asking for two possible equations. And now it's simply a question of solving both of these equations in order to get the slope of that line n. So one possible solution is that m2 is equal to 3. And the other possible solution is that m2 equals to -1/3. Now, they've left me very little space for this, in fairness. I still have to get two possible equations and I have to really squeeze that in. Don't forget, to get the equation of the line, I need to know slope and point. But back in part B, they did indicate to me that m and n both passed through the intersection of the line L and K. So it's important, since they were referring to n back here, that the information about n still continues to be true. So I've got that point from a little bit earlier. It was the point 4, 1, so I can use that to sub in to get the equation. So one option is y minus 1 equals 3 times x minus 4, and again I can tidy this up, at which point I've got an equation y equals 3x minus 11. My other option then is, of course, my slope -1 over 3. My point stays the same though, because n definitely goes through that. And my alternative answer is y equals -1/3 x plus 7 over 3. Again, I've written these in the form y equals mx plus c. If you write them as ax plus by plus c equals 0, that's also fine. On to question 2, which is a circle question effectively. So we've got C1 is circle, given it here, and we've got L as the line, and they intersect the points P and Q. Fine. So first thing is write down the centre and radius length of C1. That's really easy to do. I like when I'm doing circle questions in this format to actually write the formula above it from the log tables. It just makes it a bit easier to get at the G and the F. So I'm going to say, right, 2G equals minus 2, which means G is minus 1. 2F is minus 4, which means F is minus 2, and C is minus 20. And the reason that I've made a note of these is because I can use them to find the centre, which is minus G minus F, so just change the signs of these two guys. And the radius formula is root G squared plus F squared minus C. Just watch out for that sign change there towards the end. So root 25 or just 5. Next, they want me to find the perpendicular distance from the centre of C1 to the line L in third form. I'm going to start by writing down those two pieces of information. So I have my point that I just got, 1, 2, and my line L. And since they want perpendicular distance, I'm going to go back and look up the formula for that in the log tables. And by the way, actually, these guys are all in the log tables as well, so you can just look it up and they're all there. And this formula is absolute value ax1 plus by1 plus c all over root a squared plus b squared. So now just label your a's, b's, c's, etc. carefully. x1, y1 of course refers to the point, and a is 2, b is minus 1, and c is 5. And I'll sub those in and then evaluate it. And just don't forget to take the positive version of whatever the answer is because of those absolute value lines. And the calculator may spit it out as 5 over root 5, which is, of course, the third form answer, or you may give it as root 5. Both of these guys are actually equivalent, so just it's good to be aware of that, and they're both acceptable as answers. Now, the next part of the question says, hence or otherwise find PQ in third form. Hence just meaning use the stuff that you have so far. Now, there's a couple of ways of doing this. P and Q, first of all, what are they again? Well, they're the intersection points of C1 and L. So I suppose you could go off and find the points of intersection, but that might be a bit more work than you need to do. So maybe what we could do instead is just draw a sketch and see where it takes us. So we've got our circle and we've got a line going through it, and we know that they definitely intersect because we're told that they intersect at P and Q. And other things that I know now, I also know the centre of that circle, C1, because I found that a little while ago, it was 1, 2. And if I think about obvious things that I could join up, well, I could join up 1, 2 to PQ, and I could join up the centre to Q also. And I actually have some more values then because I actually just found the perpendicular distance here. So that's root 5. And I also know the radius from a while ago, and the radius of the circle was 5. Now, I want to find PQ, but actually, because of the way that I've drawn this, because I've brought this line out from the centre of C1 at a right angle to PQ, it actually by definition means that that line that's coming perpendicularly from the centre to the chord cuts the chord in half. So that actually works both ways. If it cuts the chord in half, it's right angled. If it's right angled, conversely, it cuts the chord in half. So it's good to be aware of that. I'm going to just call this side here, I don't know, I'm going to call it A, I think probably, just for my own convenience. And then I'm going to use Pythagoras to work out A. So A squared plus root 5 squared equals 5 squared. That means A squared is 20 and A is root 20 or 2 root 5. Now it's just important here to realise that you're not finished. So it's not just A that I want, but the whole length of PQ. But of course, as we pointed out a moment ago, the chord is getting bisected by this line, so I just have to double the A to get PQ. Like I said, you could have gone the long way around and found out what the points P and Q were, and then gone ahead and found the distance between them, but that would definitely have taken a lot more time. They did leave both avenues open to you by their wording, hence or otherwise, so you could use what came before, or you could take another route. Just be careful on that, because if they say hence and they don't say otherwise, then it really kind of ties you into using the previous information. Now that said, let's go on and look at part C. And in part C, it says that PQ is itself the diameter of another circle, C2. And they want you to find the equation of C2. So to do that, I'm going to need to know what the centre and radius of C2 is. And to figure that out, well, the radius probably won't be too bad, because if this is the diameter, then I actually already have the radius, because that's just going to be my 2 root 5. But the centre isn't apparent just yet. And actually, to get the centre, I'm going to need to know what P and Q are, and then find out what's halfway between them. So I am actually inevitably going to have to do that intersection calculation anyway. So I have written down both L and C1, and then I'm going to rearrange L. The nicest way to do that is just say y equals 2x plus 5, and then I'm going to substitute that into C1. And then at that stage, a bit of tidying up is necessary, and it's going to turn into a quadratic for me. So that resolves into 5x squared plus 10x minus 15 equals to 0. And of course, I can divide by 5 if I like to make that a little bit easier for myself. And then I have to factorise. I'm going to work on the basis now that we can all factorise a quadratic. So my factors are x plus 3 by x minus 1. And then I want to get my roots. And then to go with each of those x values, I need to get a y value. So that means looking back up here again to my y equals 2x plus 5. So I'm subbing my x values into that. And my two results for y are minus 1 and 7. Now don't forget, the whole purpose of this was to find the points p and q. So it's really 2 points that I found here. Make sure you put an x with the y, so minus 3, minus 1 and 1, 7. And now that I've found those guys, I just need to use them to find the centre of the circle for which they are the endpoints of the diameter. So to do that, I'm going to use the midpoint formula. And when I resolve that, I get a centre of minus 1, 3. Now again, what's the whole purpose of the question? It's to find the equation of C2. So I need to know the centre of C2, which I just got, it's minus 1, 3. And I also need to know the radius of C2. Now, like we said, don't forget PQ is the diameter. So it still relates back to all the previous parts of the question. And if that's the diameter, well then A must be the radius. And I have A, that's 2 root 5. And then I want to fill those into the formula for the equation of a circle. You need a reminder there for that. In the centre, H is the X value and K is the Y value. And you're not obliged to fully multiply this out, but I would multiply out the third at the end. And there I have the equation of C2. Okay, on to question 3. So in question 3, I've got a square. I'm told that in the question, and A, B, C, and D are its vertices. I'm told the equation of AC, that's the diagonal, and the coordinates of B, and I want to find the slope of AC. So nice and straightforward again. I've got the equation, I want the slope. It would help if we could see the question. So my slope for this context is m equals minus a over b. That's minus 3 over minus 7, which I'm just going to simplify to give me 3 over 7. Job done. Hence find the equation of BD. Now this requires a little bit of knowledge of the geometry of a square. And you can see in my diagram that BD is not drawn in. That's the first thing that I'm going to do. So there's my BD line drawn in. And an interesting piece of information that you need to be aware of is that if I've got a square and I draw in its diagonals, well, first of all, they all bisect each other, but also they meet at right angles. And that allows me then to get the information about BD, its slope, really easily. I already have a point, of course. So I'm just noting that BD is perpendicular to AC. So it's easy to get the slope of BD. And like I said, I have the point. So now it's simply a case of filling into the formula. A little bit of a tidy up. Again, my preferred formatting here is y equals mx plus c, and I'm getting y equals minus 7 over 3x plus 5 over 3. Again, the other format's fine as well. They haven't specified in the question. Part B, find the coordinates at the point of intersection of the two diagonals, and hence find the coordinates of D. So the point of intersection is easy to get because I can just use my two line equations. It might be better for me to actually rearrange my BD line a little bit for this. To do that, I'm going to first of all times it by 3 and then just get everything over to one side. So I've done that there. There's my BD. AC I was given previously, so I can just go back and refer to that. And then simultaneous equations as usual. This works out nicely enough, with the x working out as half. Don't forget to go back and find the y, of course, as well, just by subbing it back into either of the original lines. And y is a half there as well, so either a half or 0.5 is fine. So I'm just going to note for myself there that my intersection point is at a half. And now they want me to find the coordinates of D. So let's go back and have a look at the diagram again for a second. So that intersection point that I've just found is the point half. And they want me to find D. So now I knew what B was, and this is essentially translations. To get from B to that intersection point, I had to slide along that diagonal until I got to the middle. If I wanted to get out to D, I'd have to just continue that path. So if I can figure out what changed getting from B to the intersection, then I can reapply that exact same translation to the intersection to get out to D. So what do I mean by that? Well, okay, so B is 2 minus 3. How do I get to a half? Well, to get from 2 to a half, I have to take away 1.5. Maybe it might be easier to work in decimals with this. So I'm writing down here what happened to the x values first of all, these two guys. And now I need to see what happened to the y value. Well, to get from minus 3 up to a half, I have to add on 3.5. And so now to slide from that intersection point out to D, I'll do the exact same thing. I've written it underneath because I'm using the same translation. So if I've got a half and I take away 1.5, I'm going to be at minus 1. And if I'm at a half and I add on 3.5, I'm going to end up at 4. So that's my point D. Okay, so moving on to part C, it says hence or otherwise find the area of the square ABCD. So I think a sensible idea again here would be to go back and look at the diagram. So when I think about area in terms of geometry, there's two main shapes that we tend to come back to a lot. They're circles and triangles. There's no circles here, but there are definitely some triangles. So it might be quite useful to figure out the area of one of the triangles and then just double it to get the area of the square, okay? Because I don't know any two adjacent vertices of the square. So that's why I'm not directly trying to calculate the length of the sides. I just don't have enough information. But what I could do is I could work out the base of this triangle from B to D and the perpendicular height of the triangle. Now remember what I said before, which was that when I draw the diagonals of a square, they cut each other in half. So whatever BD is, half of that will be this distance from the intersection out to C. So distance is the first thing I'm going to find. So I've got D and I've got B and I want to find the distance between them. That's going to be the base of my triangle. So I'll fill that in and that works out as root 58. So what did I just get there? Well, I got this distance from D to B. So now the distance of the perpendicular height, if you like, this guy here, is going to be half of that. And I'm going to use that now to get the area of the triangle that I shaded. So just bear in mind that's only half of my diagram that I shaded here. I'll have to double whatever answer I get at the end. So I've got a half the base times the perpendicular height. So that gives me 29 over 2 or 14.5 units squared, but the whole square ABCD is twice that, which is 29 units squared. Okay, so finally then question 4. Write on the centre of the circle and find the radius length in terms of k. So the centre is fine because I've got the x and y terms, I can directly get that, and then the radius in terms of k because I don't have the full equation. Again, like in a previous question, I like to write in the formatting over it first of all, so it makes it easy to pick out the G, the F and the C. And from there then, I have the three values I need to get centre and radius. Again, like I said last time, these formulae are all in the log tables, so you know it's a good plan to have it in front of you, look it up. So this time my centre of my circle is 5, 2. And my radius is the root of 29 minus k, again in terms of k, because I didn't know what that value was at the end. They're still talking about the same circle in B part 1. So they're saying the midpoint of a chord of C, and again they call the circle C up here, so that's how I know it's the same circle, is 4, 1. And its length is 4 root 2. So I'm going to fill both of those pieces of information into my sketch here. So that full distance across is 4 root 2, and that midpoint is 4, 1. So both parts there are equal in length. And as we said earlier, this has implications for the rest of my diagram. So if this chord is getting split in half, then a line that joins back to the centre is going to be at right angles to the chord. So I can fill a few more bits in then. I've got my 2 root 2. Don't know how long this bit is, but when I fill in my radius, it's root 29 minus k. So I might not currently know the length of the side that I've just highlighted in yellow, but I do know that it's bookended by the points 5, 2 and 4, 1. So actually I can work out its length. That's just going to require use of the distance formula. For my own convenience, I'm going to call that A. And you'll note that before I began to fill that in, I actually wrote the formula down first of all. And that comes out as root 2. That little diagram is getting very cluttered all together, isn't it? So for my own convenience, I'm going to draw the triangle that I'm focusing on out again. And what I want to figure out is the radius length of C. So of course, that's that root 29 minus k that I have here. So I want to essentially use Pythagoras to work out the overall value of that radius. Just again, make sure you put brackets around that 2 root 2. And that comes out as 10. So that means R is equal to root 10. They didn't ask for k up until this point, but now in part 2, that's where they're going. They want us to find the value of k. So of course I know what the radius is, and I've got this expression for radius also, so I can equate them. And I'll square both sides, and I get k is equal to 19. Okay, almost there. Part C says find the slopes of the tangents to C from the point minus 2, 1. Now, if they ever ask you to find the slope of a tangent from a circle to a point, it means the point is outside the circle. So I want to start off by sketching this. So I've got my circle and I've got this point minus 2, 1 that's outside the circle. And I've got tangents coming from that point to the circle. And I want to mark in whatever else I know that might be useful. So I know, for example, what the centre of my circle is. And I know that I can join that centre to my tangents and it'll meet them at right angles. So essentially I've drawn in the perpendicular distance to the tangents. And actually that just happens to be the radius also. So I know the perpendicular distance from a point to a line. The only issue is I don't have anything for the equation of the line. I do have a point on the line. So what I'm going to do is I'm going to create an equation for that line with some unknown information, which is in this case the slope. So I'm going to call the slope m, and I'm going to try and get m. And it kind of makes sense that I might not know m, that I might be putting into the equation, because I've actually got a couple of different values for it. That'll give me access then to my couple of different answers. So I've begun to make my tangent equation. I'm just going to tidy it up, and I'm going to tidy it up into the form ax plus by plus c equals 0. We'll see why in a second. So it'll look like this: mx minus y plus 2m plus 1 equals 0. Take a couple of lines to sort that out. And at that stage then, I want to work with perpendicular distance. So here's the formula that I'm looking at then. So perpendicular distance, ax1 plus by1 plus c all over the square root of a squared plus b squared, absolute value there, of course. This is the reason that I wanted my tangent in this format, to match up the formatting that was required in the formula here. Do just be careful with your a, b and c values that you're going to take from the tangent. A is going to be m, b is going to be minus 1, and the c is going to be the whole constant bit at the end with no x and y attached, the 2m plus 1. The 0.52 is the x1, y1 that I'll be using in the formula. Okay, so what am I going to have there then? Well, I'm going to be filling in the information from my tangent and the point and the distance, and that's because the distance from the point, 5,2, to this tangent line, both sides really, is root 10. That's where this information here is coming from. And the easiest way to get rid of my square roots and my absolute value lines all in one fell swoop is just to square both sides, because that'll get rid of absolute value lines and it'll get rid of the square roots. I know normally with absolute value we take a plus and a minus version of the answer, but when there's roots in it, they're going to have to be eliminated anyway. So I'm going to tidy this up and multiply it out a little bit. So I've squared most things here. I've squared the root 10 and got 10. I've squared underneath here and I've got m squared plus 1. I just haven't squared here yet. I wanted you to see that this resolved into 7m minus 1 first of all. And now I'll square that as well. And while I'm at it, I'll bring up the m squared plus 1 and times it by the 10. And you can see at the stage it's definitely going to turn into a quadratic. And there's my quadratic. So 39m squared minus 14m minus 9. No division possible here, I'm afraid. If you don't like the look of it, you can always go off and use the minus b formula if you want. It does actually factorise though, to give us 3m plus 1 by 13m minus 9 equals to 0. And all they're asking me to get here is the slope of the tangents. So I just have to solve for m. So I'm nearly there. And at the end of all of that, my solutions to my slopes are m equals minus 1 over 3 and m equals 9 over 13.